Hello and welcome back to Maths 14. Okay, so we're going to be moving on this time, and we're going to be looking here at square roots. Um, so we're going to be trying to incorporate square roots into the previous material. So um, so one thing we could say is that if we look at a squared, that's the same as a times a. These numbers are factors, and in a square, the area here will be a squared. Um, so yeah, but then we need to kind of look at how we can generalize. Um, and so one of the things we can say here is that for any x greater or equal to 0, there exists. There exists is actually you could replace that with a symbol actually, but that's a very important thing. There exists. Um, okay, so there exists, and obviously for 0 you can have it as well. That's why you've got the or equal bit to it. There exists a positive number. Its square is x. So at any point, so this number x, obviously in a positive, a rational kind of space here. This number x is going to be equal to some number squared. So if it's 9, it's 3 squared. If it's 25, it's 5 squared. 121, 11 squared, whatever it might be. So the principal square root square root of x is root x. So root x squared equals x. And of course, from what we looked at, that if we have like like minus 1 to the 1 is minus 1 to the 1 is minus 1. Minus 1 squared is 1. Because of this thing, where we look at when we have the odd powers, we get a negative number. We can see that if we do the negative square root of x squared, we get x as well, because it's going to be so there's that as well, because we're taking it to the because anything to the even power is going to be positive, isn't it? Including negative numbers. Okay. But the principal one is this. So we could say this is positive, this number here. Yeah, I've actually mentioned it, didn't I? Okay. So the principal one is this. This is another root, another square root. Okay, so there's another square root there. So okay. All right. So square root is unmultiplying So it's like finding the components of x into two equal factors. You can imagine like x is like, you know, a large kind of structure with kind of modular pieces or something, and well, two big modular pieces, I suppose, and yeah, and it's finding those numbers which are going to well, I suppose that would be additive, wouldn't it, if you did it like that? But it's unmultiplying. But it's interesting, isn't it, this term? You think, well, unmultiplying, is that division? No, that is not division. It's something else. It's unmultiplying. It's looking in this sort of, it's like in like the multiplication world. It's like there's a huge like world of multiplication in the multiplication world. And anything in this world we could imagine can be is only doing multiplication. So you couldn't have like 121 to make this. There's only multiplication that's allowed. No addition or subtraction is allowed. That'd be a way of looking at it. And then we can know that we're going to get 11 and 11. And then these are equal. All right, so yeah, so there's that anyway. So yeah, so 2 is root 2 times root 2. 361 is 19 times 19. 289, 17 times 17, things like that. Just put that dot there. But yeah, so that's how it works. All right. So the next thing then is okay. So next thing is going to be writing a square root as a power. Okay, so obviously this is what we actually be doing the whole time up to now, really. So if we look at remember this rule: a to the m times a to the n, a to the n plus n. Yeah, so 2 squared times 2 squared equals 2 to the 2 plus 2 equals 2 to the 4, right? So that's what we were looking at here. So yeah, so this rule, we know this is for a fact. So if m is 20, so if if this was all equal to 1, for instance, m was 20, then we would need n to be minus 20, and then we get 0, and then a to 0 would be 1, something like that, yeah? So yeah, so that's what we're going to have to look at here. So we can rewrite this. So we've got x, and we can put another number in here. Another number in here with x. Okay, so the factors are equal, right? So it's not just going to be this one box here. Yeah, so it's basically like, yeah, so we know that it's going to be like this. So the box plus a box is going to be x, right? All right, so yeah, and what we can do, in fact, we know that x to the 1 is going to be x, so we can write it like that. So this is going to be x to the, so the 2 lots of box. So if that was 3 and that was 3, it'd be to the 6 or something like that. So yeah, so 2 lots of the box. So x to the 2 lots of box is going to be x to the 1. Okay, so yeah. Now, so yeah. So what we could write, in a sense, is like if we just look at the line and above it, on this sort of like, like the power line or something like that. This is probably not the best way to look at it, but what we got here, 2 lots of box equals 1. Because box equals a half. Okay. So therefore, square root of x equals x to a half. And we can see how that works, can't we? Like if we do square root of x squared, so obviously there's going to be x. Now it's going to be x to the half squared. Okay, so if we look at the powers here, if we look at the rule, so the rule that I wrote down for this bit, how did I write it here? I wonder if I can put that bit in there. I think I might be able to actually. Just trying to think how I would get to this. I mean that's all. X to the half squared is going to be x to the 2 halves. How did I actually get to that? I wonder if I could just do the. Yeah, this is a bit more complicated, isn't it? Because it's actually. I mean, you can see what happens. That half times 2 is 2 halves. This is the problem when you go up. Yeah, I suppose if the squared had been in here, it would not be as good. But because it's outside, that's interesting, isn't it? That x to the half squared equals x to the 2 over 2. So what number are we going from? The number we're going for is x to the half, which is the square root of x. So say we did have x was 9. Let's just do 11 actually, may as well. X is 21. Then x to the half will be 11. And x to the 1 will be 121. So look, you can see how it's growing. It's growing in a very large fashion, isn't it? So in here, we've got like 2/3 and 3/4. Yeah, like I say, I'm not going to focus on this now. There's no real point focusing on this now because I'm going to be talking a lot more about it. Mm.